bring the motorcycle up to 30 kilometers an hour,
Okay.
which we'll see on the speedometer here.
Okay.
And it's got cruise control, so I just leave it. It's awesome.
Motorcycles have cruise control?
This has cruise control. This is
I've never heard of that.
so perfect. It's
Okay.
perfect for the demo
Exactly.
because
You don't have to sit
I'm
here.
not, no. Because when cruise control is perfect because when it accelerates, if I'm not manipulating
All
it,
right.
then yeah.
See,
No, well, for the demo, there's no trickery. Like that's what I'm saying. I could be, you know.
all right.
So what I'm going to do again is bring it up to rotational equilibrium again, steady state speed.
Mhm.
These are our 3 switches for our 3 coils. You can see them.
Mhm.
And on this side, they are in motor mode, okay? Which means that once this is fully integrated, these coils operate as motor coils, receiving power from the battery and operating like motor coils, okay? Then, once the EV is up to cruising speed,
Mhm.
above 30 kilometers an hour, they get switched over from motor mode to regenerative acceleration mode, and they recharge the batteries while accelerating the bike.
Got it.
And we'll see the acceleration on the tachometer, hopefully, but we won't see it on the speedometer. Like, it doesn't go from 30 kilometers an hour to 35. It stays at 30 kilometers an hour, but that is more sensitive. The RPM is more sensitive.
Got it.
And the point is, each coil delivers, right now, delivers 2.5 amps,
Mhm.
okay, at 12 volts. Each coil is connected to a 12-volt battery.
Mhm.
So, and the point of this demonstration is to show that when we have 3 coils charging, 2.5 amps each, about 7.5 amps, the more coils we put on, the more we recharge the batteries, and the faster the bike goes.
Wow.
I'm hoping we'll see that on the tack, but we won't. And this is designed to have 12 coils,
12?
12. So,
So
and
this
this,
is just what? Each
3,
one, 1, 2, 3.
there's 3 in there now just for simplicity.
Yeah, gotcha.
I've noticed that when you do demos, if you have 12 coils, an engineer who's skeptical or just a prick might say, well, you're motorizing one of them or you're whatever.
Mhm.
But when you have 3 and the wires are, you know, everything is done so that it's clearly, you can trace everything. If you, and so, but when this has 12 coils on it, at 2.5 amps per coil, that's 25, 30 amps.
Got it. And that's how
Okay.
we can measure that on.
Well, no, what I'm saying, 25 to 30 amps going to these batteries at 30 kilometers an hour. The motor is, at that speed, is consuming between 0.9 amps and 3 amps.
Mhm.
Kind of get the idea of what I'm,
Got it.
you're not going to have to plug it in.
Got it.
And if you,
Okay.
and if you take these coils out
Mhm.
and put that coil in that was delivering 3.5 amps, then you get
Even
the
more.
same effect but more. And the more current that you deliver from a RegenX coil, the more acceleration you get. The more current you deliver from a conventional coil, the more deceleration you get.
Got it.
So above 30 kilometers an hour, regenerative acceleration, I'm going to show you that.
Mhm.
Each time I add one, this current meter goes up and the speed goes up. I hope we will see it on the oscilloscope. Then when I'm down around 15 kilometers an hour, when I do the same thing as I did there,
Mhm.
the speed will go down. And I'm only changing one parameter.
That's all you're doing is change the coil.
I'm just changing the speed of operation of the coil,
Got it.
okay? That's really important to understand. I'm not fiddling with anything, I'm just changing the speed of operation.
Mhm.
And if you understand how the operation of the coil, you'll understand, and it's explained in there.
Got it. Okay.
Not from a patent standpoint, but enough for the average person to say, okay, I can see what's going, I can get an idea of what's going on. Oh, look. Okay. So you can't leave the country now, sorry, but it's not